to show off. I'm waiting for like the no-hander. You know, they have no-handed cartwheels. You know, aerials. Yeah, I mean, that's just where they run and go, and they go. It looks like a cartwheel, but their hands are like back, like up or something. I don't know. It's amazing what they can do, huh? All right, equation. I think we need to start with the general picture. Because I don't have any, like I can't say I want dx dt. I don't have x. I need a picture, right? Need something to work off of. I'm going to move this up just a little bit so y'all can see it. All right, so here I have this circle with the center. I have the person standing out here. And then I have some arbitrary line that connects the person, the two people together, right? Let's call that distance z. Okay, call that distance z. Now I can say that I want dz dt, right? I want to know how fast z is changing, the distance between them. So I can say dz dt. Do I know when I want that? When they're 120 meters apart, which is z, isn't it? So this is exactly at the moment that z is 120 meters.
You know they're 100 feet, or you know that she's 100 meters from the center.
You know that she's 100 meters from the center. Oh, so you know that the distance from here to here, you're saying that's 100.
Yes.
Do you all agree with that? Does that ever change? No. That's always fixed, right? So I can put that in the general picture.
And the runner is always 50 meters.
The runner is always 50 meters from the center. So I could, if I want, draw this and label that 50, and that I could put in the general picture also, right? Yeah? Good. Yeah, but I still don't know. I still don't have anything for the no yet.
Would it be?
You know what?
ds dt.
ds dt? What's s? Where's that in my picture, though?
You know the speed of the runner.
Do you see why I'm asking you that question?
Yeah.
Because if you say, you know, if you want to call the speed of the runner s, then we know ds dt. I agree. But where's s in the picture? Because remember, we're going to have to come up with an equation relating the two. And if s isn't in the picture, you're not going to get an equation, right?
Circumference?
Yeah.
Would it be the z because the z is what's changing?
Z is changing, but that's what we want. We do want to know what z is.
The circumference.
What about the circumference?
7 meters per second around. She's going around the circle, so it's the circumference, right?
Yeah.
So
That's her linear speed. She's running at that speed in a circle, right? You're on the right track.
What is the
No pun intended.
what is the
wouldn't that be the circumference? Like dc dt?
Yeah, okay. You're starting to chip away here.
Would it be theta?
Theta? How do you mean?
Because she's changing the angle from the horizontal and
RP. Okay.
Yeah, so look, as she moves around, that's exactly right, good. Look, as she moves around, I know how fast she's going around the track, right? But in terms of my picture, the only way that I see that I'm going to relate her speed around the track is if somehow I convert her speed around the track to somehow correspond to that angle. So as she's moving around the track at a constant speed, isn't that angle changing at a constant speed? And if I include that angle into this triangle, then I have a triangle with some sides and maybe I can get to it. See, we've introduced the variable that goes in our picture. We just need to actually figure out how fast is theta changing. So how fast is theta changing? It's not 7 meters per second. That's how fast she's running around the track.
oh, we have to figure that out. It's gonna be like 80 something.
So let me give you an example so we can go back, because this is a pre-cal thing. let's say I had a circle, okay? And let's say the circumference of this was 200 meters. All right? Let's just say. And I start running around this track, and I'm running, and this is totally made, well, I'll make it realistic. I'm running at 5 meters per second. How long is it going to take me to go around that track? So I start here, start running. I have to go how far?
You have to go 200 meters.
I have to go 200 meters in, right? It's going to take me how many seconds? 40 seconds. Everyone agree? 40 seconds is going to take me to go around that track. Yes? How much of an angle do I turn through in that 40 seconds? 2 pi, right? 360, but we're going to stick to radians. So I actually went 2 pi radians per, and it took me how long to do that? 40 seconds. Which I could change this, just 2 and 40, I could change that into what? Pi over 20 radians per second. Do you see what I just did? I just reduced the fraction. 2 pi over 40 would become pi over 20 radians per second.
So we know,
Yeah? Do y'all see it?
yeah, do we know the circumference of this thing?
Do you know the circumference of that circle?
We can figure it out.
I hope so. We have the radius of it, right? If you have the radius, you can get the circumference. So there's quite a bit of work that we are having to do here on this problem. All right, so what I'm trying to find right now is the angular speed of my runner. I have the runner's linear speed, and I'm trying to find their angular speed. I'm using pre-cal language now. So what I'm going to do is first find the circumference. Just like I did here, I made up this problem. What is the circumference of this particular circle? The circumference of this circle is 2 pi r. And it's a 50-meter circle. So this is going to be 100 pi meters is the circumference.
She's running it, so is that her equation?
Yeah, circumference is 2 pi r.
Oh, yeah, this is going to equation. Or is this
Oh no, this is just me doing scratch work. Yep, this is just scratch work here. I'm trying to find, here's what I'm trying to put here, d theta dt. Because I know how fast the angle is. Right? As she runs around, that's like a second hand on a clock. It's moving at a certain speed. It's not changing, right? I want to know how fast that angle's changing, but I first have to convert her linear speed around the track into an angular speed around the track. So I find the circumference of the track first. Now I figure out how long it takes her to run around this track. So how long is it going to take her to run around this track? Let's keep it exact. Let's not actually get a decimal.
100 over 7?
It's this distance divided by 7. Right? Just like before, if we have a 200 meter track around and I run at 5 meters per second, then you told me it was 40 seconds, right? Same thing here. I have a 100 pi meter track. I'm running at 7 meters per second, which means if I take this 100 pi and I divide it by 7, this is going to be, you could put meters here in meters per second. The meters would cancel, the second would flip up, and you would get your seconds. And I'm just going to leave 100 pi over 7 seconds. That's how long it takes her to run around the track.
What's her angular speed?
Nope, this is just how long it took her. Now what I want to know is what angle does she turn through in that time? One loop around the track?
So that's
2 pi
2 pi.
divided by this. Because look, we're looking for the change in theta over time. What's the angle that she went through? 2 pi. How much time did it take her? This much time. So if I take 2 pi radians and I divide it by the total time that it took her, 100 pi over 7, seconds, then this is going to equal radians per second. And how about those pi's? They're gone. And this 7 can flip up and become a 14 up there, or I could reduce that, couldn't I? 7 over 50. No, we'll keep it in radians. Keep everything in radians until maybe your final answer if you want to go to degrees. Keep everything in radians, just you'll save yourself a lot of trouble, a lot of heartache. All right, I'm going to leave that there. That was all scratch work. This is the second to last problem in the homework section. The second to last. You know how they usually save the harder ones for the end? This is why this one is like this. It's a tougher one.
I'm not good at geometry as it is.
All right.
So is this part of the general picture? Good.
Well, yeah, because I put theta in the picture, didn't I?
Yeah. So that's theta.
Well, that's d theta dt, right? We know how fast this angle is changing. I can tell you right now that that angle changes at 7/50ths of a radian per second. That's how fast that angle is changing as she runs around. The hope that we had here was that we were going to somehow be able to connect z to her speed. But we couldn't, so we converted her speed to her angular speed, and now we're going to connect her, the distance between them to her angular speed, hopefully. Or connect that to that. So how can I connect those together? Hmm? What do you mean sector it? I think I know what you mean, but let me draw that picture a little bigger. How about that? We have this picture. Here to here, that's 100. From here to some arbitrary point here, this is 50. From here to here, this is z. And I know that this angle is theta. I need to connect z and theta together. I don't really like the way I drew that. Let me make that a little smaller. There. Z is r times theta. How are you getting that?
Sector formula of circle.
Oh, okay, good, yes. But this is not a sector. So what you're using is this. If you have an angle like this, theta, and this is r, and you have like a pizza slice, then the area, you're doing the length of this, right? This length from here to here, S is what we call it in pre-cal, is equal to r theta. But that's a curve along a circle. This is a straight line. So that's good that you saw that, but it does not fall into this category. Side angle. Side angle side. I don't know. What do you do with side angle side? I'm not saying you're wrong. I want you to stumble upon this. See if someone can stumble upon this. Cosine. All right, you can throw out SOHCAHTOA if you know what I'm talking about. You can throw all that out. Sine, cosine, tangent, because all of those are based upon right triangles. This is not a right triangle. So in pre-cal, we study right triangle trigonometry. And then later on in pre-cal, we start introducing you to some other things that help us solve triangles. Two very important ones. Law of sines and law of cosines. Law of sines you use when you have like the angle that corresponds to a side and you're looking at it with the angle, a different angle in its corresponding side. Here we have an angle and then two sides here, and I don't know. I want you to.
We can do side angle side. Go from there. Make Z120 and then do off sides with Z.
Can you make Z120?
Or is that me doing it constantly?
That means you've held it constant, and that means you get electrocuted. Well, you're right there. I gave you, it's one of two things.
Can we make a right triangle, right?
I said there's two things in law of sines and law of cosines. Law of cosines. Law of cosines. Now let's see why it's law of cosines. Law of cosines, look on your formula sheet, okay? I mean, who has their formula sheet? I want to write it down the way it appears. Can I borrow yours, Laura? Thank you. I'm just going to write it the way it appears here.
Can we make 2 right triangles?
Yes, you could make 2 right triangles, but then you'll be here till next week. And I prefer that we're not here till next week. Okay, so the way it appears here, I'm going to draw it exactly the way it appears in your formula sheet so that you can understand what they're saying here. A, B, C, capital, then little c, little a, little b, and then they say a squared equals b squared plus c squared minus 2bc cosine a. All right. And there's 2 other equivalent formulas. Thank you. But here's what the law of cosine says, or what we use it for. If you're trying to find this side of a triangle, okay, a squared, okay, that side right there, squared, should be equal to this side squared plus this side squared minus 2 times this side times that side times cosine of this angle. Which means that if you're trying to find that side of the triangle, if I know this side, and this angle, I can use that formula. Was there a question? But either way, that will allow me to set up a relationship. Now, why not law of sines? Law of sines says this. Sine A over little a equals sine B over little b. And you can also flip them over. You could say A over sine A must equal B over sine B. Why can't I use that? Because that looks like a cleaner formula. It's the same picture, by the way.
You need to know a secondary at least.
Yeah, so look, if I just go with, I'm trying to connect this side, right, this to this, I could say z over what? Z over sine theta equals b over, so b could be this side, or no, this side, b over what? Sine that angle, and now we don't have that angle. And I don't want to go mess with that. All right, I hope you're on board here. This ship is leaving the dock here. All right, I just erased the formula I needed, but that's okay. So from this, I'm ready for my equation. Here it comes. Law of cosines. Help me out. Z squared must equal 100 squared plus 50 squared minus, not yet, 2 times 100 times 50 times cosine theta. There we go. Do I have an equation that relates theta and z together? Yes. A lot of those things are constants, okay? There's my equation. Z squared equals, all right, let someone do this for me. 100 squared is 10,000 plus 2,500?
Yes.
So 12,500? Whoa, no. Yes. 12,500. I almost put 1,250. All right, that's these two together, right? Now here, these are attached to that cosine with multiplication. So I'm just going to figure out what that is. What is it? Minus 10,000, right? Cosine theta. Just cleaning things up right now. I'm happy with that formula. I think that's ready to be differentiated. implicit with respect to time is,
2z dz dt.
yeah, I'll put it up here. 2z dz dt equals,
Well, that's all.
derivative of this is 0, right? A constant attached to a function, so it's just going to come for the ride. Minus 10,000. Derivative of cosine is negative sine of theta. It'll be positive.
Times theta. Or derivative of derivative of theta.
D theta dt. Do not forget chain rule on cosine. Derivative of cosine something is negative sine of it times derivative of what was inside. Derivative of theta is d theta dt. Whew. That's it. That's it. I mean, that's all.
We don't know theta.
We can clean that up.
We don't know theta, but we can get theta. Let's take a look at this. What do we know? What do we not know? Now we can fix things in time. Do you know z at the instant? And we never drew the instant, did we? This was 50, 100, and at the instant in time, that's 120, isn't it? That picture? Friend, stalker, runner, center of track. So this was z. So I know what z is, so I'm okay with that. Do I know dz dt?
Yes.
Well, that's what we want, right? So I'm happy it's there. D theta dt, do I know that? Yes. Theta, I don't know. Right? But I can now come back to this picture. Right? I can come back to this picture. Theta is this angle right here. Can you solve for this angle if you know all the sides? Yeah, what formula will I use? This formula right here, law of cosines. Look at this formula right here. Didn't we just use that a second ago? Before we differentiated it, that was it, right? If I fix things in time now, I know what z is, right? Z is 120. What's 120 squared? 4. Right there. Look at what's the only thing left in here? Cosine theta. I can solve that for theta. Would you agree? Okay, I need someone with a calculator to help me. Subtract here. Take 1440, subtract 1250. What do you have? I can't do basic arithmetic. 19 something?
1900.
1900 equals negative 10,000 cosine theta. Divide by 10,000.
Negative 10,000.
Negative 10,000. You get negative 19 over 100.
Yeah.
Is cosine theta. Yeah? But I need what?
Theta.
I need, well, negative, but the negative is going to come out. I need sine of theta, right? Yeah?
Negative on the derivative.
Nope. I just need to know what sine theta is. Look, I'm in pre-cal right now. Someone just told me a cosine theta is negative 19 over 100. I need to know what sine of the angle is instead. So what I would do in this class, or at this point, if I were in a pre-cal class, is I would draw a reference triangle. I would say I have a right triangle. Actually, I know it's not in, I could draw it not in the first quadrant. What quadrant would I be in?
Second quadrant.
I could be in the second or the third, right? Or wait, no, cosine. No.
Positive.
It's cosine's negative means that you're either here or here. So what I'll do is, let me put it here. That would mean this is 100. The angle is actually here. I know you want to put it in there, but don't. And then this would be negative 19. Agreed? And then I want sine of theta, so I need that side over that.
Pythagorean theory.
Pythagorean. All right, I think the wheels are almost off this bus completely. So let's just call that y and solve for it. So y squared plus 19 squared equals 100 squared.
Isn't it minus it?
A squared plus b squared is c squared. Oh, that's nice.
361.
98.1? 98.1?
I got
98.1.
Did you square 100?
Did I what?
Did you square the 100?
Oh,
Yeah, I did.
I'm sorry.
Yeah, square root. Don't forget square root.
Right.
So sine would be 98.1 over 100. That'd be sine of theta. So you could plug that in there, and I think we'd be there. So I don't think I'm going to go anywhere because I want to talk about our exam, but this would be 2, z is 120. dz dt was what? What we're looking for? Equals negative 10,000. Let's make it plus. The negative and negative is plus. Sine of that is whatever 98.1 over 100 is, which is 0.981, times d theta dt, which was,
7 over 50.
what was it? 7 over 50? Okay. And that's just arithmetic. Get all this together, divide 240 on both sides, and you're done. And that's your answer. That's the distance at which they are moving apart.
It's gonna be on a test.
Wow, huh? No, I'm going to talk about the test. So do you see the difference between, hey, there's a circle, which its radius is growing at 2 feet per second. How fast is its area increasing? Do you see the difference between that and this?
Yeah.
Okay. I snuck something by you here. I could have drawn my triangle this way. And then our answer would have been negative 98. And that would have been negative here. And that would have changed our answer to negative. So which one is it?
We don't know. Both.
It's both. Think about the situation. Remember,
It can be both.
it could have been 120 meters and she's running away, and then it would be growing, or she could be coming back towards the stalker, and then that would be shrinking, right? So that's why, I mean, that's beautiful to me. The math is telling us, like, it's somewhat, how does it know that there's two scenarios here? It's just like, it's just built in, it's like woven into the fabric of the universe somehow. All right, you want to talk exam? Of course you do. Clear your brains for just a second. Breathe in, breathe out. There was one more example I'm not going to do. It's the ladder problem. Didn't we do that?
No.
We didn't talk about the ladder? Okay, I do it in the video, so don't worry about it.
The ladder falling?
Yeah, the ladder falling? Okay. Didn't I introduce the whole idea with the ladder?
Not in class, maybe in the
I didn't? I didn't do my ruler up against the wall over there?
No.
I wasn't pulling it away like that? Okay, well, we don't have time to do the problem. All right, everyone clear their brains for a minute? Okay, you might want to jot this down. The test will be on Tuesday. Have a good weekend. I'm kidding. All right, so look, this is just an idea of like things I've asked in the past, all right? So like I gave them a function and asked for the fourth derivative. Now, don't confuse that with implicit differentiation. Remember with implicit differentiation, it was hard to even do the second derivative? Those are those problems where you had to like y double prime. There was 4 problems like it in the homework, and they were tough. I'm not talking about that. I'm talking about if I give you a function, take the derivative,
Take it
then again, but nice functions like sine and polynomials where the powers just keep going down. Just clean. Just show me you can do a derivative quickly on some basic functions. Like the quiz, something with powers. Remember everyone tried to do the quotient rule on that one that should have been split up?
Yes.
Okay. I gave them one of those also. I did give problems where you had quotient rule, product rule. Just demonstrate. Give me the raw derivative. Couple of chain rules. I see. Let's see. 2 chain rules here. I also did a quotient rule that had a chain built into it. Please, again, this is not a copy of what your test will be. This is just an idea, right? That puts me about at that was like the first 8 problems on the test. All right? Then some implicit differentiation. You know, I just give them an equation that you can't solve for y. I ask for y prime. So you have to do your implicit and solve, move things around. Ask for the equation of a tangent line using implicit differentiation. We did that not last class, the class before. This is interesting. I gave them just some random equation and I asked them to find dp dt. So it's just like, remember I gave you this one right here? PV equals nRT. If I asked you to, nR capital T, if I asked you right now to find dP dm, then you could. You would have to treat everything as if it depends on m. So when you go P and V and you take the derivative here, you'd have to do what? Product rule. And then over here, this is a constant. The derivative of capital T with respect to m would be dt dm. But you'd have to do product rule over here. So I asked them to do something like that also. That got me through, that takes you up to 11 problems. Of those problems on their test, it was, let's see, 25, 35, 45, 55. That was about 65% of the points. Then I gave them 4 related rate problems and asked them to do 2. So they got to choose. Related rate problems. These word problems that we've been doing. I'm not sure if I'm going to follow that same process. What I've been leaning more towards trying to do is maybe I'll give you like C level, B level, and A level problems. So like when you get to the part where it's related rates, I give you a C level problem, which means that let's say the problem is worth 10 points, right? Let's say related rates, that question on the test is worth 10 points. If you choose the C level problem, then the highest you could get would be like 7.5 out of 10. If you get it right, you get 7.5 out of 10. Because you chose to do the problem that said the radius is growing at a certain rate, how fast is the area growing? That's very basic, right? So you get credit, but you don't get what an A level problem would be, which would be more in lines of like the cone, things coming out of the cone, or the one where we had to relate 2 equations together. That's A level. There you can get the 10 out of 10. Does that make sense to you?
So the other 2 would be bonus questions.
There wouldn't be bonus, no. You would have to choose and commit yourself to it and do it.
Which one is
You
which?
can only choose one.
That's right.
Would you tell us which one is which, or?
Yes, I would tell you, yes. I would say this is your C level problem, B level problem, A. And I'd probably give you 2 C levels, 2 B levels, 2 A levels, and you get to choose. Like I'm going to do this C level problem, and that's what I'm doing.
If I do more than one,
Yeah.
I get one right.
You know, I have this conversation a lot with students. If you do more than one, do you get bonus or, you know, extra credit? Or if I do 2 of them and one of them's wrong, one of them's right, will you grade the right one? Yes. Not normally, because I'm giving you an option, all right? And because of that, I'm making you choose. And you have to choose and you have to stick with that. Because if you don't know which one of those is right, then that actually shows maybe that you're not quite sure. I want you to be sure. So if you don't feel confident with these harder problems, just stick with the C-level problem. It's not going to kill you, your grade, right? Because you have a lot of other stuff that you're going to be graded on.
If they're both right, will you take the highest level?
You have to tell me which one you want me to grade. You can't just do 2 and then just be like, I'm going to let him choose. If you don't tell me which one to choose, I just won't grade either one.
So C is 10, A is 20, and D is or whatever.
C is 10. I don't know how to explain it any more. Look. Okay, so look, for example, on this test, there was, I believe, 160 points total from problems 1 through 11. And then 80 points for problem number 12, which was the related rate problem. That's the way this test was for them. So that means 2/3 of the exam was all the derivatives. 1/3 of the exam was, can they do related rate problems? All right? I gave them 2 to choose from out of 4. The first one, a plane's flying horizontally. Okay? Second one, snowball melts. That's like a problem in the homework. That's a sphere, it's shrinking. Gravel's being dumped onto a conveyor, from a conveyor belt into a pile that's a cone. That's like the water in the cone problem, except reverse. Water is going in, gravel is going in, it's creating a cone that's getting bigger as opposed to the other way. And then the last one was a rocket fired. We didn't do that one. But anyways, these are all in the book. So if this were the same format as yours, and I gave you A level, B level, C level problem, if it were 80 points, then the maximum you could get if you did the A level problem would be 80 points. You could get all 80 points. If you did a B level problem, the most you could get is 8.5 times 80, which would be 60 something, 64, 65 points out of 80. If you did a C level problem, you could get at most 56 points out of this. Or so, 56, 58. I hope that makes sense. I'm not trying to make life worse, but if I myself say, hey, look, I'm going to pick a middle of the road related rate problem and put it on the test. There are going to be people who fail the test because of that one problem. You know, or like get a really low grade because of that one problem. I want to give people who just kind of get the idea to show me they get the idea. Now they can't be an A student because they know the basics. If you want to be an A student, you have to be able to do the harder ones. So I hope that that's what you're gathering from this. I'm trying to give you the opportunity to be an A student without actually getting wiped out by the problem. What do you think? Y'all gonna be ready Tuesday?
I don't think we have much choice.
Yeah. Okay. Hope you have a good weekend. Y'all study hard, okay? I want y'all to do well. I mean, I can only hope for you, you know. Anybody that wants their old quizzes or something back? I have old stuff up here. First test?